So hello again everyone. So here we can see the question that has come in the organic chemistry part in 1 marks for GATE 2021. So as you can see that in this question we have been given CH2I2 ZnCu zinc copper couple. So and they have given us four options in which two are below the plane and in which two the cyclopropanation has happened above the plane. So this is basically the conformation of the alkene has to be kept in mind. So here we have been given the alkene as such. So this is basically a cis alkene first of all, and then they have given the SiMa2PH, which is the bulky group above the plane. So if we draw this in the conformation, which is in the Sawhorse type of conformation, so then what we get is that the Me actually goes below, and as you can see the SiMa2PH is above the plane. So a very bulky group being above the plane lets the attack to happen below the plane. So this is basically a Simmons-Smith reaction, and here the conformation is very important. So this name reaction, Simmons-Smith reaction, is a cyclopropanation reaction which happens with the reaction of CH2I2 with zinc copper couple. And here, as we can see, due to the presence of the bulky group SiMa2PH above the plane, the cyclopropanation happens below the plane. So in the below the plane, it doesn't have too much bulkiness, because there is one H group and there is one methyl which is also a little bit away from the olefin bond. Hence, this is actually a very common substrate. So the SiMa2PH group, if it is present above the plane or below the plane, regarding to that, the attack would actually happen, and this is due to the bulkiness of the SiMa2PH. So a very similar reaction also happens in case of epoxidation reaction. So as you can see, so this is cyclopropanation. Here the option A is the correct option, where the below the plane attack has happened. And let us check the the similar mechanism of the epoxidation reaction. So we will not see the mechanism, but if like MCPBA was given, which is metachloroperbenzoic acid, which facilitates the epoxidation reaction, so then we will see that in the case of using MCPBA, the epoxidation, that is the oxide ring, that is the three-membered ring, will also form below the plane. So this is actually a similar type of reaction, and I don't know if you know about the Claydon book. So please follow an organic chemistry book which is very good, which is Claydon, Greaves, Warden authors. These are the four authors of that book. So that book also covers this reaction in quite details, the MCPBA reaction. Yeah. So going to the second question of this part. So here also we have been asked the major product in the reaction, and this is actually a photochemistry reaction that has been given. So as you can see that the substrate is a cyclohexyl moiety with methyl groups and OH group present. There is only one OH group present, whereas in all the other cases the methyl group has been given. They have given us NOCl, HNu and HCl. So this is also a named reaction which is known as the Barton reaction, or in some places it is also known as the Barton oxidation reaction in the photochemistry genre of organic chemistry. So as you can see, let us check the mechanism of Barton reaction. So what is happening in this reaction is that we have got the OH, and it reacts with NOCl being NO plus and Cl minus. So the lone pairs of OH actually attacks the NO plus part, and what we get is that it becomes like O plus, O positive, and there is the N double bond O, and then the Cl minus that is present, it actually abstracts the H and it becomes ONO. So the functional group is ON double bond O. And in this case what happens after that is that the delta hydrogen, that is the hydrogen present in the sixth position, it is actually abstracted. So we'll check how it is done. So first of all, the ON bond actually undergoes homolytic cleavage under photochemical conditions. After that, as I said, the hydrogen present on the sixth position becoming like a cyclic transition state, six-membered cyclic transition state, stable transition state, the delta H is abstracted by the O dot, and the oxide radical actually takes the delta H and it becomes the OH, and we get a carbon radical formed there. And we also have the NO dot which is present in the medium of the reaction. So the NO dot actually basically forms a bond with that particular carbon radical. So there what we get is that there is the CNO, H2 single bond, N double bond O. So there are two H's present there. So what happens is a simple rearrangement, and this rearrangement actually forms the more stable C double bond NOH type of bond, which is the oxime, the CH double bond NOH. and this oxime actually sometimes undergoes another rearrangement to form the C triple bond N, but as here HCl has been provided, so oxime actually undergoes hydrolysis, and that hydrolysis yields the aldehyde. So what we get is that there is the OH and there is CH. So in the options also for this question, all the four options contained aldehyde group, and hence what we get here is that there is OH present, and in the delta carbon there is the CHO present. So the overall reaction, let us just check the overall reaction because the mechanism was a quite long one. So as we can see that there is OH and there is CH3 there also. So NOCl, HNO and HCl causes the formation of a CHO bond. So this is basically a functional group transformation in photochemistry. Yeah, so thank you for listening to the video, and please follow part 2 for the next questions in 2021 chemistry, gate chemistry. Thank you everyone, and as I say, keep writing organic chemistry reactions, they will become easier.